the fourth step or fourth service, which is going to be called as PGP compression. What actually is PGP compression? So a default PGP compression is going to be the message after applying the signature but before the encryption. So this has the benefit of saving a space both for email transaction as well as for the file storage. The placement of this comparison algorithm, which is going to be indicated by a letter Z, and for the decompression it's going to be indicated as Z inverse. So in general, how it's going to get happen? The signature is going to be generated before compression for two reasons. The first one is going to be, it is preferable to sign an uncompressed message so that one can store only the uncompressed message together with the signature for the future verification. If one signed a compressed document, then it could be necessarily either to store a compressed version of the message for later verification or to recompress or decompress the message when verification is going to be required. This is the first reason before compression. Second, even if one more willing to generate a dynamically decompressed message for verification, so PGP compression algorithm presents a difficult one. So the algorithm is not deterministic. So various implementations of this algorithm which achieves a different trade-off in running the speed versus compression ratio, and as a result produces different compression forms. So hence, however, these different compression algorithms are going to be interoperable because any version of this algorithm can correctly decompress the output of any other version. So by applying this hash function and the signature after compression could constrain all PGP implementations to the same version of the compression algorithm. And the message which is going to be encryption is applied after the compression to strengthen the cryptographic security. So because the compression message has less redundancy than the original plain text, so that cryptanalysis is more difficult. So the compression algorithm used here is going to be an SIP. So the fourth parameter, email compatibility. What actually email compatibility? When PGP is used, at least a part of the block to be transmitted is going to be encrypted. If only the signature service is going to be used, then the message digest is going to be encrypted with the sender's private key. If the confidentiality service is also used, the message plus signature are encrypted with one-time symmetric key. Thus, a part of all the resulting block consists of a stream of 8-bit octet binary numbers. However, many electronic mail systems only permit the use of block which containing the ASCII text. To accommodate this restriction, PGP provides a service of converting into a raw 8-bit binary stream to a stream of printable ASCII characters. So the scheme which is used for this purpose is going to be radix 64 conversion. So here each group of 3 octet of binary data is going to be mapped into 4 ASCII characters. So this format also append a CRC to detect a transmission errors. The use of this radix 64, which is going to be expands a message by 33%. Unfortunately, if you're going to see that the session key and the signature portions of the message is relatively compact and the plain text message has been compressed. So in fact, the compression should be more than enough to compensate for the radix 64 expansion. For example, the report an average compression ratio of 2.0 using a zip compression algorithm. So if we ignore the relative small signature and the key components, the typical overall effect of the compression and expansion of this file length would be very less. Therefore, thus there still an overall compression of about of and 1/3 of it's going to be done over there. So on one noteworthy aspect of this radix 64 algorithm is that it blindly converts the input stream to radix 64 format regardless of the content. Even if the input happens to be an ASCII text. Thus, if a message is going to be signed but not encrypted, the conversion is applied to the entire block. The output will be unreadable to the casual observer. So which provides a certain level of confidentiality. As an option, PGP can be configured to convert to radix 64 format only the signature portion of the signed plain text message. This enables the human recipient to read the message without using an PGP. So PGPs would still have to be used to verify the signature. Let's see a diagram which is going to show the generic transmission of a particular transmission diagram. So here the figure shows the relationship among the four services so far what we discussed over there. One transmit send us a signature which is going to be generated using the hash code of the uncompressed plain text. Then the plain text plus signature is going to be compressed. Next it's going to be, if a confidentiality is going to be required, then the block compressed data is going to be encrypted and concatenated along with the public key encryption schematic encryption key. Finally, the entire block is going to be converted to radix 64. As we have seen that the information which is going to be sent to the signature. So if signature is going to be needed, which is going to generate the signature, along with the signature and the message, both are going to be concatenated and which is going to be delivered over there. The later compression is going to be done with the help of a zip algorithm, and later the confidentiality is going to be assigned. If it's going to be required, a confidential is going to be required, as we mentioned, it's going to be done with the two encryption process, encryption, symmetric encryption as well as public key encryption, both are going to be done over there later, which is going to be given for the conversion of radix 64 data. So such formats is going to be get transmitted from the sender's end. On the reception end, if you're going to see about that, the incoming block is going to be first converted from the radix 64 to binary. Then the message is going to be encrypted. The receiver, which is going to recover the session key and decrypt the message. And after that, message is going to be get decompressed. So the resultant block, which is going to be then decompressed. If the message is going to be signed, the recipient has to retrieve or recovers the particular hash code and compare it for its own calculation of the hash code. Such a way the message is going to be recovered at the reception end. This is going to be the actual process of compatibility verification from the particular process, PGP services. The fifth operation or the fifth PGP service is going to be called as segmentation. As we are aware about, segmentation is nothing but fragmentation. It's another constraint of an email is there, that is usually in maximum message length is going to be fixed over there. So if such cases, what happened, the PGP automatically, which is going to divide the particular message into segments, and it's going to encrypt the messages as per the segment, and an appropriate length is going to be fixed by the PGP itself. Then on the reception end, the segment must be reassembled before the decryption process. Then later the decryption is going to be happen and the original message is going to be delivered to the recipient. So these are the 5 operations which have been performed by the pretty good privacy as authentication, confidentiality, compression, compatibility, and segmentation. So the summary of PGP, if you're going to see about that, so here the function which is going to be different functions we have come across over there. One is going to be digital signature, and the algorithm is going to be a DSS or SHA algorithm, as well as RSA or SHA is going to be used over there. So which is going to be a hash code, which is going to be creating an hash code from the message for, or else this message digest is going to be encrypted using a DSS algorithm or as an RSA algorithm with the sender's private key, and which includes the message over there. And if it's going to be message encryption, we are going to use a symmetric encryption process as a triple key TES or IDEA or CAST algorithm, which is going to be used with an RSA or DFI-LMN. And the message here is going to be encrypted using the particular DES, triple DES algorithm with a one-time session key, which is generated by the sender. And the session key is going to be encrypted using a DFI-LMN or RSA algorithm with the recipient's public key, and which includes the messages over there. The compression technique or compression function is going to be used with the zip algorithm. Here the message may be compressed for a storage or a transmission using a zip algorithm. And for the compatibility purpose, we are going to use an algorithm called as and Radix 64 conversion. So here, which provides the transparency for email applications. An encrypted message may be converted to an ASCII string, which uses a Radix 64 conversion. And as usual, if you're going to see about this one, we have come across with this video an introduction about an electronic mail security. What actually the pretty good privacy which is going to do, what kind of operations are going to be there, we have come across over there, notations which have been used in the PGP, and 5 services are operational descriptions of a PGP: authentication, confidentiality, compression, compatibility, and segmentation we have come across. And how actually this particular process is going to be message is going to be transmitted, the transmission and reception of PGP message we have seen with the diagram, and we have summarized with the PGP services. Hope that this video will fulfill to understand about the electronic mail security of pretty good privacy. So if you have any queries, kindly you can contact me or you can text me. Thank you for watching this video. Thank you.